All right, so 22, I'm looking at it, and I do understand what happens to students sometimes. They get nervous, they don't bother checking their work, and they write down an answer that's quick, but that's wrong. So what do they write over here? And they think of, like I'm going to, antiderivatives and things like that, and they think, oh, gee, it's got to be x cubed over 3. And they say, oh, the antiderivative sign is minus cosine. And they say, oh, plus c. I don't want to forget that. But unfortunately, what happens again, if you differentiate this, you would not get back what you expect to get back. So this is 100% wrong, all right? So what I want to do is I want to say, I wonder if I can do it. And that's always my question, can I do that? And that looks like it might be doable, who knows? I'm going to use integration by parts, by the way. So let me put this over here. So I'm going to say u dv is uv minus v du. All right, so I got to select a u, and if I do that, I can say u is x squared. And if I do that, I'm forced to take the dv to be sine x dx. So this is pretty easy to do. I'm not going to say it's going to work, but it's easy. It's 2x dx. And over here, the integration is always a little more difficult, but what differentiates the sign would be minus cosine of x. All right, constant integration will be done at the very end. So let's write this down, see if it got any better. So you get x squared, and you get sine x dx equals, let's see, uv, so it's going to be minus x squared cosine of x, and then I get minus, let's be careful over here, so it's going to be the v, so it's going to be plus then, because minus and minus is plus. We got a cosine there. Times the du, which is 2x. I'll put this over here, dx. So I'm looking at this, I want to point out, I did reduce the power, and that's promising news to me. So what I got to do now is I got to see if I can do that. And I kind of like to throw things away, and I'm actually going to erase it. I'm not going to just cross it out. I'm going to say I'm done with this. And I want to start again. I'm going to do integration by parts again. So I can reuse the letters again because I just erased that. And I'm going to say u is equal to x. And that makes the dv equal to cosine x dx. Well, du equals dx. And v would equal, well, sine then, right? Let's write this down then. It's going to be minus x squared cosine of x plus 2. Well, let me remind you, I'm doing this over here. U dv uv minus v du. All right, let's write it down. And I'm looking at it, and I'm going to say x sine x. And then minus, let's see, the v, that's sine x. And then the du, which is dx. Well, you know what? Things have gotten substantially easier now. Let's write this over here. What do you get? Minus x squared cosine x plus 2x sine x minus, well, let's be careful before I say minus, right? So what's its antiderivative? Is actually minus cosine, so it's going to be plus 2 cosine x plus some constant of integration. I'm going to say I did that, and let's take a look, see how I did. And I'm always wondering, did I get the right answer? And the answer is way over here. And I'm going to see, did I get 2x sine x? I did, right there. Did I get 2 cosine x? I did. And I know there's a lot of going around. Did I get minus x squared cosine x? Yeah, right over here. They were in different order, by the way. And did I get the plus c? I did. All things are fine. Thank you.